All right, here we go. We're going to forget about tangent for a day here and start focusing on sine and cosine today. They have a pretty special relationship. Make sure you got your calculators out, ready to go. I have no idea, but maybe while we were doing these sine, cosine, tangent problems, and some of the problems we do like a part B where we'd have to, after we found an angle, we'd have to find a side. And I said, well, it doesn't matter how you do it, we're all going to get to the same answer. And I don't know if anybody ever thought, well, how is that possible? If you use sine, how are we going to get to the same answer? And it's true, we would. All right, I'm going to show you why today. All right, it didn't matter if I use sine or cosine on a certain problem. First thing I need you guys to do real quick, I don't have actual numbers, but I have variables labeling the sides of this right triangle. Can you please real quick find the sine of A? So going from angle A, what's the ratio of sine? Going from angle A, what's the ratio of sine? Not looking for any numbers or anything, just what over what here. Here you go, 9. What do you got for me? Y over Z, yes. Opposite over hypotenuse, Y over Z. All right, now I have a big challenge for you and your group to accomplish right now. Find me another ratio that is also Y over Z. So obviously you can't use sine of A. All right, so find me another ratio that if I did this over this, it's going to be Y over Z. Okay, I'll give you about a minute to talk about in your group. What other ratio would be Y over Z? Okay, hopefully you've had time to discuss in your group what other ratio would give me Y over Z. 25, what'd you and your group come up with? Cosine of C, yes. If you do cosine of C, that's also adjacent over hypotenuse Y over Z. So you see, we got some things that are equal here in the triangle. We did sine of angle A and then cosine of C. Now let me ask you this question. What do you know about angles A and C? They're not congruent. Get that out of your head. What do I know about angles A and C? I already have a right angle at B. So these two have to add to what? 90, right? It's making them complementary. So what's so special? They are complementary. AKA add to 90. So we don't have, I'm not really comfortable right now having you guys come up with a conclusion. Here's where we're going to go with your calculator right now. Emma, give me an angle between 0 and 90. 70. Everyone right now, sine of 70 in your calculator. And look at that decimal for me. Sine of 70. Then do, right underneath it, cosine of 20. Same thing. All right, let's keep this train going here so you do notice a distinct pattern here. Caitlin, give me another number between 0 and 90. 10. Cosine of 10. Find that decimal right now. Cosine of 10. What do you think I'm going to have you plug in next? Sine of 80. One more time. Teddy. 63. Sine of 63. Guess what I would have you plug in next? Cosine of 27. Yes. What are we trying to say about sine and cosine? They will always be equal to each other. When what? When what about their angles? Complementary. So let's write the conclusion in here we just found out, which is we can start with sine. The sine, and all I'm going to put here is any angle. The sine of any angle, actually I should put, excuse me, any acute angle. Because this doesn't work if you go above 90. Any acute angle is equal to what? The cosine of, how do I find that? What am I looking for now? The cosine of 90 minus your angle. All the time. Okay? All the time they will be equal to each other. And I'm going to make this even more, I don't know, maybe this is just me and I don't think I'm going to get the reaction I need to, but sine and cosine are what we refer to, as you see at the top of your page, today's topic, cofunctions. Cofunctions. Watch, ready? Sine, what's this called? Cosine. Sine, cosine. They're cofunctions. They are equal. Stop. They are equal when what do we know about their angles? Complementary. All right, let's try to apply it now. Express the following as equivalent trigonomic functions using cofunctions. Basically, here's what I want. Use another ratio other than cosine and another angle for me. Cosine of 20 is going to be equal to what out there? I don't want you to use cosine again, and I don't want you to use 20 again. I want a new ratio with a new angle measurement. So cosine of 20 should be the same value as 23. Excuse me? Sine of 70. Everyone all right? Why they're equal? Sine and cosine are always equal and their angles are complementary. Number 2 here, sine of 37 should be the same value as 15. It's cosine 53. We all right, because now here's where it gets a little tricky. Number 3. You have x and x plus 20 are the measures of two acute angles. And the sine of x is the same value as the cosine of x plus 20. Find x. And I know some of you right now see the equal sign, and you're just going to do this. No. You're not picking up what I showed you at the beginning here. If I set sine and cosine equal, what do I know about their angles? They have to be what? Not equal. They have to be complementary. Yes. If I set sine and cosine equal to each other, their angles have to be complementary for that to be true. So what equation should I write now? Not x equals x plus 20, but x plus x plus 20 have to equal to 90. So 2x plus 20 equals 90. 2x equals 70. X ends up being 35. Okay, there. I don't want to go too fast. So we see what we're doing here now. If sine and cosine are going to be equal, you better tell me their angles are complementary then. Okay, express cosine of 83 as a function of an angle less than 45. So again, what do I want? I want something other than cosine, and I want your angle to be less than 45 now. So cosine of 83. Cosine of 83, that'll be equal to, cosine always goes with sine. What's your angle, though, going to be? Y7. I got to add to 90 if you're going to set them equal to, if you're going to set sine and cosine equal to each other, they have to be complementary. All right, we're going to end this with 2 pretty tough questions here. X is the measurement of an acute angle. The sine is x plus 15 and the cosine of 45. Find the exact value. All right, I need to find x first. First of all, not true. Don't get in that habit. If I'm going to set sine and cosine equal to each other, what should I know about their angles? They are complementary. They are complementary. Plus 45 equals 90. So what do I have there? X plus 60 equals 90. X is equal to 30. But they didn't ask me for X. Take a look. Take a look. They did not ask me for X. They asked me for the value of the sine of X plus 15. So let's plug X in. What am I looking for? The sine of 30 plus 15, which is, yes, 45. Where can I get that value from? And we're not looking for sloppy decimals here, honors kids. How can I somehow get it in fraction radical form, the sine of 45? 45 ring a bell? 45 ring a bell? What were the side lengths? X, X, and far from done here. Sine, 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 opposite over hypotenuse. So everyone pick a 45. Opposite. Doesn't matter which 45 you pick. X over hypotenuse. X radical 2. Anything you want to do with that? Oh, not yet, not yet, not yet. Not yet, not yet. What can I do here? What can I simplify? You can take care of the x's. What am I left with? Don't tell me nothing. What am I left with on top? A 1 over radical 2. I know this is a long one, but what's the problem with that one? Can't have a radical on the denominator. How do you want to get rid of it? Multiply top and bottom by. Should have set this up a little differently. So go ahead, multiply top and bottom by radical 2. You end up with radical 2 over 2. Yep. Upper level problem right there. Ready? We all good? Last one. R and T are measures of two acute angles, and I know R plus T equals 90. What's the cosine of angle R going to be equal to? This one's going to be tricky. Well, can you guys forget about the multiple choices right now? Forget about the multiple choices. Cosine of R should be equal to the sine of what? Forget about T. Forget about T. 90 minus angle R, right? Because if that was 60, you'd tell me that's 30. You do 90 minus it, right? So we're all good there. Cosine of R is equal to the sine of 90 minus R. That's not a choice. That's not a choice. Bless you. Maybe a diagram. What's the name for 9 minus R? These two angles add to 90, right? Everyone is in agreement there? 90 minus r would give me what angle? T. So this is the same as the sine of t. Yes, no, let me, again, before I get to sine of t, cosine of r, we know you do the sine of 90 minus whatever the angle is. That's what we've been doing all day, right? Sine of 90 minus the angle. 90 minus 83 gave me 7. We're all good here? 90 minus r. Well, if I take 90 degrees away from r, I'm going to be left with the other angle because they add to 90. We all right there? Which would be t, sine of t. Before I let you go, because you can get a bunch of problems done, you may not think it in 4 minutes, but you can. Quickly, notice we put a little note here on your homework tonight. This is theta, that's a variable. It's like x, it's like y, that's an actual 0, so don't get the theta confused as 0, okay? You can get a bunch done right now. And one of these types I put on tomorrow's quiz. Only certain ones I want you to do.